We're going to do a little Algebra 1 skills review. We're going to have a series of Algebra 1 skills that we will review to begin this school year. And to begin with, this first lesson is going to be on algebraic expressions. There's really a twofold objective here. We want to learn what it means to evaluate an algebraic expression, to take several terms and come to a final single number answer to an expression after we substitute for the variables and perform the order of operations correctly. And then to wrap up this lesson, we're going to remind ourselves, what does it mean to simplify algebraic expressions by combining like terms? Or sometimes you'll see me use the letters CLT, combine like terms. So let's just get right to it. My first example, several examples, will involve evaluating algebraic expressions, and that's going to involve two parts. We're going to first of all substitute numbers for variables, and those will be given to us. And then after substitution, we're going to follow the order of operations, also known as PEMDAS. And in case you forgot, the P in PEMDAS stands for parentheses first. Any operation contained in parentheses, we will need to simplify those first. Then we move on to exponents. We'll simplify those. Then we will take care of any multiplication or division, moving from left to right through our expression. And then finally, if we have any addition or subtraction, those will need to be taken care of from left to right. So this first example tells me that x is 4 and y is negative 2. So first of all, I'm going to replace x with 4, and I'm going to replace y with negative 2. I think it's a good idea anytime you are substituting for a variable, a number replaces a variable, I think it's a very good idea that you put that number that replaced the variable in parentheses. Okay? So following PEMDAS to the letter, I would take care of any operations within parentheses. Well, I don't have any operations contained in parentheses. These are just single numbers in parentheses. Operations would mean addition, subtraction, multiplication, or division. So I can skip over the P. I don't have any exponents in this expression. I do have multiplication, don't have division, but as I move from left to right, I'm just going to take care of all the multiplication. 3 times 4 is 12. And I'm going to bring down this minus sign, and then 4 times negative 2 is negative 8. I'm going to bring down everything else because nothing else involves multiplication or division. And now finally, I'm going to take care of any addition or subtraction. And as we look at this problem a little closer, we notice that we actually don't have subtraction at all because subtracting negative numbers is addition. So I'm just going to make this become plus. And again, subtracting a negative means addition. So I'm going to make this become plus. And so really, I'm just going to be adding from left to right. 12 plus 8 is 20. 20 plus 4 is 24. 24 plus 2 is 26, and that's my final answer for this example 1A. Okay, example 1B, very similar. I'm going to replace x with 4. So there are two x's. Both of them get replaced. I'm going to replace y with negative 2. Notice how I put the numbers that replaced variables in parentheses. And now I'm going to follow PEMDAS. Any operations contained in parentheses would be done first. Well, there are none. These are just single numbers. Don't have any exponents. I do have multiplication. 4 plus 2 times 4 is 8. And I'm just going to do these one at a time just to slow this process down. So I went ahead and multiplied here. I also have division contained here. 8 divided by negative 2 is negative 4. And I notice I still have multiplication here at the end, and I'm going to treat this as subtracting 2 times negative 2. So I'm going to be subtracting negative 4. I'll put this in parentheses too, since I'm treating this as plus a negative, which is another way of saying subtraction. So going left to right, I do addition, subtraction. 4 plus negative 4 is 0, and 0 minus negative 4, that's another way of saying 0 plus 4 is 4. Okay, we're going to keep doing this same type of thing, but when we get to this next set of problems, we're going to be involving exponents that we did not have before. So once again, I'm going to replace c with negative 3, and I'm going to replace d with 5. Now, using parentheses in place of these variables, parentheses around the numbers that will replace the variables, causes me to avoid a common mistake here, because now I'm able to do exactly what the problem says to do. It says to square whatever c is. And I've written it so that I will be squaring, in this case, negative 3. And negative 3 squared is 9. Subtracting 5 squared is 25. And I put those together, 9 minus 25 is negative 16. And that is my answer for letter C. Letter D, once again, I'm going to substitute negative 3, and then in the parentheses 3 minus 5, minus, again, negative 3 squared. Okay, so according to PEMDAS, I would do operations within parentheses first. That means I'm going to take care of 3 minus 5 first, and that's negative 2. Okay, the next letter of PEMDAS is the E for exponents. So I'm going to take care of negative 3 squared, and negative 3 squared is 9. All right, and then the next part of PEMDAS is multiplication and or division from left to right. There is no division, but we do have multiplication. Negative 3 times negative 2 is 6. Bring down minus 9. And now we're left with the operation subtraction. 6 minus 9 is negative 3. And that's my answer for letter D. Okay, letter E. I'm replacing D with 5. Notice how I took literally in place of D, I put 5 in parentheses, and the minus is outside. The square is also outside. Okay, D is 5 minus 2 times negative 3. Okay, I'll put a big bold set of parentheses outside to indicate the outer bookend parts of that parenthesis set. All right, so we would take care of operations within those parentheses first. So I'm just going to rewrite all this other stuff and simplify inside the parentheses. Well, inside the parentheses, I've got to follow PEMDAS. So before I do subtraction, I must do multiplication. Okay, and now continuing simplifying within parentheses, 5 minus negative 6, that's another way of saying addition. 5 plus 6 is 11. Okay, very good. Now I'm going to take care of the exponent, and you got to be careful here because the way it's written, it says to square whatever D is, and then in effect you're going to multiply that result by negative 1, or you're going to make it the opposite of whatever D squared is. Well, D squared will be 25. Well, the opposite of D squared is negative 25. And then 4 times 11 is 44. Now we're ready to combine these together. Negative 25 minus 44 is negative 69. That's my answer for Roman numeral 1E. And then letter F, I went ahead and gave you the answer. I gave this to the class to work by themselves. I'll just go ahead and work this one for you. So I'm going to replace x with -3. And I'm going to replace y with -5. Okay, and if you want to use brackets for the actual group, that would be okay, or you can just make a big set of parentheses. It's really for organization purposes, just to differentiate the outer set with what's going on inside the group. Okay, and then 2 times -3 plus -5, and then once again, I'll just make these bigger. Okay, now let's work on inside. The P part of PEMDAS is inside the parentheses. We need to follow PEMDAS. So we multiply first. 3 times -3 is -9. And I'm just going to do this a step at a time, so hopefully you can follow along. 2 times -3 is -6. All right, continuing working within these parentheses, -9 minus -5. We can change both of these to plus. -9 plus 5 is -4. And -6 plus -5 is -11. Okay, we've taken care of the operations contained in parentheses or grouping symbols. Now we're ready to do multiplication. We do multiplication before subtraction. 5 times -4 is -20. Minus 2 times -11 is -22. And subtracting a negative again means addition. So -20 plus 22 is 2. So that's how we got our final answer. Okay, part 2 of our lesson. This will be pretty quick. Just a quick review of what it means to combine like terms, simplifying by combine like terms. Well, we first need to make sure we understand what it means to be like terms. Like terms are terms that have the same variable, unless they're constants. Obviously, 2 constants can be added or subtracted. But when it comes to terms that contain variables, to be like, they have to have the same variable, and not only that, the variables have to have the same exponent. So here's a pair of like terms, 2x and 3x. Here's a pair of terms that are not like, 5y and 10y squared. So we can combine like terms. We cannot combine unlike terms using addition or subtraction. But when terms are like, we can add or subtract the coefficients. And what I mean by coefficients are the numbers in front of the variables. 2 is a coefficient, 3, 5, and 10. So the operation will be performed on the coefficients. Okay, let me show you some examples. Here I have a pair of like terms, 2y and 3y, so I can add those together and I can make 5y. 2 plus 3 is 5. Another pair of like terms, 4x squared minus 10x squared. So I just operate using the coefficients. 4 minus 10 is -6x squared. Okay, so for this one, let's start with the higher exponent first. And I've got a couple of like terms. Got a couple of x squares. So when I put those together, -5 minus 3 is -8x squared. And then these other terms are also like. They both have x, and they're both x to the first power. So +2 plus 4 is +6x. And this is preferred. You may have gotten these terms correct individually and just switched the order. But this is really a preferred order because this is called standard form. Standard form for a polynomial means that we start with the highest exponent at the first term and then we just count down in succession from there. So, all right, so that is my answer for that example. So let's do a few more and that will wrap up this first lesson. So first of all, we need to identify any like terms. I'll put a blue square around a set of like terms, 2x squared. Don't forget the negative, negative 4x squared. Here, this would be like negative 1 times x squared. So we operate with the coefficients. 2 minus 4 is negative 2. And then negative 2 minus 1 is negative 3x squared. All right, and then maybe a green circle around these other like terms just so you can see them. We have a positive 5x and a positive 1x. So operating with the coefficients, 5 plus 1, positive 5 plus 1 is positive 6x. And so that would be my answer for letter A. Letter B, I gave you an important note here. When you're simplifying by combining like terms, you must remove parentheses first, and normally, most of the time, that's going to mean the distributive property. So in case you forgot the distributive property, we're going to take negative 2 in this case, and we're going to multiply it by each of the terms in the parentheses. And by the way, this is an S. So this reads as negative 2 times the quantity r plus s minus parentheses 2r plus 2s. All right, so getting rid of the parentheses by using the distributive property, I would have negative 2r minus 2s. This is the same thing as distributing negative 1. So negative 1 times each of these terms will be minus 2r minus 2s. And now I'm ready to combine like terms. I got a couple of r terms. Negative 2r minus 2r makes negative 4r. And then I got these other s terms. Negative 2s minus 2s is negative 4s. That's my answer for letter B. And then finally, letter C. Again, we need to get rid of these grouping symbols, these parentheses, by doing the distributive property. So when I distribute y to both of these terms, I get y plus y squared minus 3y squared. And then I'm distributing negative 1 to both of these terms. I get negative y minus 1. Okay, now let's group like terms. I got a couple of y squared terms, plus y squared, 1y squared, minus 3y squared. 1 minus 3 is negative 2y squared. I got a couple of y terms that are like y minus y is 0. Any number, that's what a variable is, it represents a number. A number minus itself is 0. So those are going to just go away, and then I'm left with minus 1. And that's my answer for letter C. Okay, so that wraps up this assignment. I have given you a homework handout because this isn't part of your regular textbook. So if you look on RenWeb and you look at the document called Lesson 0, we're calling this Chapter 0 because it's review. Lesson 01 homework handout, these problems on that page or pages, and then I hope you're able to complete these successfully, but if you have any questions, let me know.